and flew with them until 1947 when he joined the Edo Company on Long Island testing. Pleasure to welcome you to the General Electric Aviation Lecture. As always, we are very grateful to General Electric for their support that makes this series possible. And also we're grateful to W. Bell for providing the ability to videotape all these for our record, a historical record. Just a quick announcement. The next lecture is Thursday, January the 17th, and Bob Hoover will be the speaker, and he will talk about some of his flight testing and air show flying and accidents. Should be very interesting. Tonight's speaker is Stefan Cavallo, who will talk about his experiences as an NACA test pilot in testing the P-51. It's generally accepted the P-51 as one of the best, if not the best, fighters of World War II, but as is common with most aircraft, it didn't start out great. It wasn't exactly a dog, but you could hear a quiet bark now and then if you went by. But Steve Cavallo will talk about the testing and the changes that resulted from that testing that eventually made it what it turned out to be the best fighter of the war. Steve learned to fly in the civilian pilot training program at NYU in 1940 and 41 while he was obtaining an aeronautical engineering degree. Following graduation in 41, he joined NACA as an engineering test pilot and flew with them until 1947 when he joined the Edo Company on Long Island testing float planes. In 1949, he gave up aviation as a career, but still flies as a private pilot. In fact, I think he said he just got his commercial soaring ticket, a rating, I should say. Since 1949, he has been an appraiser specializing in aviation-related material and is recognized as one of the best in his field. He's been a very good friend of this museum for many years and has helped us innumerable times to identify and evaluate many items and memorabilia without any charge, which has been very helpful to us. So please welcome Steve Cavallo.
Thank you, Don. The P-51s came in a high-speed, low-level dive. They flew down between the hangars, they strafed the airfield, and they shot down a kamikaze plane. And as they went by the boy standing on the roof, he cried out, "Cadillac of the sky, Cadillac of the sky." The movie was The Empire of the Sun, and the boy was right. Now, there are many opinions as to the best World War II fighters, and it's always slanted in the direction of the plane the pilots flew. So to end the argument, the Kalamazoo Air Museum recently had a fly-off between an F-6F Hellcat, an FG-1, which is an F-4U Corsair, the P-51, and the P-47D, Thunderbolt. The author concluded, quote, "It all depends," unquote, but that the P-51 was the best fighter. And General Robin Olds, who was a World War II and Korean ace who had flown both propeller-driven and jet-driven aircraft, called the P-51 a fighter pilot's dream. Now, the British Commission came to New York in the spring of 1940 to buy P-40 airplanes, but Curtiss Wright was booked, so they turned him down. So the British went to Dutch Kindleberger at Inglewood, California, because they were pleased with the AT-6 Harvard trainer that they were making for them. And they wanted Dutch to build the P-40s under license, which would have taken about 120 days. Dutch said, "We can build you a better plane in 120 days." And based on his proposal and the time constraint of the 120 days, they gave him an order for 300 airplanes at slightly under $50,000 apiece. He had the plane ready in 117 days. And when they asked Dutch, "How did you pull that rabbit out of the hat?" he said, "If you want to pull a rabbit out of the hat, you have to put a rabbit in the hat," which inferred that they probably were working on the design before the British showed up. And the British coming to Dutch was a question of necessity meeting opportunity. The P-51 that they showed him was an ME-109 look-alike. In fact, it looked so much like the Messerschmitt that they painted stripes on it on D-Day to keep the troops on the beach from shooting at it, and they still try to shoot it down. Now, although the prototype was ready by August 1940, the engine didn't show up until October. They had it designed around the Allison engine that was being used in most of the current fighters at that time, American fighters. The premier one was the P-40 airplane. And when it finally showed up in October, North American Aviation was so anxious to get their plane in the air that they had the propeller and the engine installed in one day, and they had the airplane flying in 4. Unfortunately, it crashed on its 5th flight, and it's still conjectural whether it was due to the pilot's fuel mismanagement or it was engine failure. But in any event, it had established the fact that it could go 387 miles an hour at 13,500 feet, which was 35 miles an hour faster than the P-40 or the Spitfire. And there were 2 reasons why it was better. One was that it was compound curves. There wasn't a straight line on the vehicle. It was flared and fared in every area. This is the B model, but the only difference that would be obvious to you would be that there was a 3-bladed propeller on the prototype as opposed to this 4-bladed one, which is on a Rolls-Royce engine. The second reason was that it had a laminar flow wing. This is the laminar flow wing. This wing is a conventional wing, and it's on a Focke-Wulf 190. This is the laminar flow wing on the P-51. The difference being that the conventional wings, the thickest part was about 1/3 of the way back, and on the laminar flow wings, it was 2/3 of the way back. It gave it sort of a whale-shaped look. Now, just to give you an indication of what a clean machine these 2 factors produced, if we, on a scale of 100, if we gave the P-40, which was the current best fighter, 100 units of drag, the XP-46, which was a new secret fighter that Curtiss was working on and was coming down the chute, everybody was waiting for it, would have had 78 units of drag. The P-51 prototype would have been 67 units of drag, and the P-51B, when it was cleaned up by the NACA wind tunnel, full-scale tunnel, was 50 units of drag. So the P-51 had half the drag of the P-40. Now let me divert for a moment and look at define some of the aerodynamics involved with the P-51. This schematic, and I must thank Ron Davies for this, shows a main wing section and a tail section of a conventional airplane. The main wing has a tendency, a main wing of an airplane has a tendency to roll down, a rolling moment that tends to pitch it down if it's unsecured, unsupported. The stabilizer and elevator provides a download that prevents the wing from pitching down or rolling down. The pilot can control this download by the elevator. Now, some of the definitions we should concern ourselves with is the chord line, which is an imaginary line that starts at the leading edge of it's an imaginary line, starting at the leading edge and going to the trailing edge of a wing. The relative wind would be defines the direction that the air comes in at the wing at. And the angle between the relative wind and the chord line is called the angle of attack. Now, if the angle of attack gets big enough, in other words, if in this case the relative wind comes in at an angle like this, airflow breaks down over the wing and the wing stalls. Now, some of the incoming air strikes the bottom of the wing, impacts, and causes positive pressure. The rest of the air goes over the top of the wing. As it goes over the top of the wing, it pinches down. It's squeezed by the air above. And when it pinches down, it speeds up. Another way to look at it is that the air at the front has to go through a longer distance to get to the back than the air at the bottom, and therefore it's traveling faster. Now, if you remember your high school science, Bernoulli's theorem says that when you speed up air, the pressure goes down. So the negative pressure on the top of the wing and the positive pressure on the bottom causes lift. Now, drag comes about because the air that goes over the top of the wing can't make that curve past the point of maximum thickness, and it separates. So past this point of separation, you're going to get the air slowing down, stopping, and reversing. And cause, when it does that, this slowing, stopping down, and reversing, it creates an area of turbulence and drag. Now, we had a P-47 at Langley Field that was covered with tufts, wool yarn tufts. And at 450 miles an hour and 10,000 feet, when you looked out of the cockpit, you could see that the tufts in front of this point of maximum thickness would flow aft very nicely. But back in here, the tufts would rotate, stand up, or move, or flow forward. You can see the same thing if you'll follow a convertible down the highway, and you'll notice that when the air comes over the windshield, which is equivalent to this point of maximum thickness, it will go over the top, come down, and hit the people in the back of the head, and you'll see their hair sticking up and moving forward. Now, the other law that we all learned in high school I'd like to bring to your attention is Newton's law, which says for every action, there's an equal and opposite reaction. So when you try to slow down and stop air, it's going to try to slow down and stop you. There's another definition, which would be Mach number, which of course is the relation of the speed of the airplane to the speed of sound. Speed of sound at sea level on a standard day is 743 miles an hour, and it decreases as you go up. So when we talk about Mach number 0.83, we mean 83% of the speed of sound. Or if we say the air over the wing is 1.4, we mean it's 40% faster than the speed of sound. Now, why, we're back looking at the same two wings, only they're vertical now. Why the laminar flow wing was such a good wing? And incidentally, it was a wing invented by NACA and was offered to the industry, but North American Aviation was the only one to pick up on it and use it, and the P-51 was the only wing, the only fighter that had the laminar flow wing, which had a great deal to do with its success. This slope, leading from the leading edge to the point of maximum thickness, is a lot gentler than the one in the conventional air forces. And therefore, the pressure change along that wing was gentler. As it went through the point of maximum thickness, it was smoother. It was a more uniform, a more even transition. And so the pressure change was less intense. And of course, this area of turbulence and drag back here is considerably smaller than the area of turbulence and drag behind a conventional wing. So it all added up in a way to a wing that could handle the air more gently, if you will. And it was a more efficient and effective wing. For the same amount of lift, there was less drag. And that's what airfoil design is all about. Now, for those of you who are still awake, we're finished with Aerodynamics 101, and we'll get back to Inglewood, California. So the British, having seen the prototype and what it could do, ordered 620 airplanes. And the Army Air Corps, so the Army ran the aviation services up till 1947. So anything we refer to, we're going through the Army. The Army got two samples. I think they were free. They were production model number 4 and number 10. The agreement was that any Allied government buying military equipment had to supply samples to our government. The British didn't get their P-51s until October 41. They were concerned. They had two concerns. One was the Allison engine, which they considered a low-powered engine. And the second thing was delivery reliability. They were concerned that they were dealing with a company half the world away. Things had to come by freighter. And our government was beginning to build up a war machine or an effort, and they were beginning to take over more and more aviation production. So the British made a decision to go with their Spitz, their Spitfire, and their Rolls-Royce engine. And they would use this as their primary fighter. And they used our P-51s for ground attack and photo reconnaissance only. There was a Major, Thomas Hitchcock, who was a military attaché in London, in the American London Embassy, who suggested that they try the Rolls-Royce engine in the P-51. And the result was the P-51B, the first picture we saw, which was a when they put the Rolls-Royce engine in the P-51, the cleaned up P-51, the one that NACA had enhanced its drag characteristics, turned out to be an airplane that was capable of 440 miles an hour at 35,000 feet. What they had installed in it was a Packard Maryland engine. The Packard Motor Company was building a Rolls-Royce engine, which they called the Maryland, here in the United States, but they were building it exclusively for the Canadians and the English. And of course, the English, their worst fears were realized because we took over the production of the factory. When the plane was shown to General Hap Arnold, he ordered the Army to buy it. Now, they were reluctant to buy it because they already had a P-38 Lightning, a P-39 Airacobra, a P-40 Tomahawk, a P-47 Thunderbolt, and they had this secret XP-46 coming down the chute. But what they were jealous of and what they wanted was a dive bomber. They thought the Stuka was a great weapon, and they wanted one too. So they took the P-51 and they stuck dive brakes on the bottom and slotted flaps on the top, and they called it an A-36 Invader, and sent it out to do battle. And it flew in China as a dive bomber and in Africa, the African theater. They also were interested in the noise-making ability of the Stuka. Apparently it would make a horrendous noise, the Stuka, and would demoralize the civilians and the troops. So we ran some tests, and we found out that the most effective noise-making devices was either a Coca-Cola bottle or an organ pipe tied on the end of the wing. But I'm sure they didn't use either one of those. What was happening was, of course, the P-51 trying to fly to a target with a 500-pound bomb underneath of it was really working with its one hand behind its back. And by that time, the fighters were more numerous. And when it got to the target at 12,000 feet and pushed over into a vertical, pulled out at 2,000 feet, all of that time it was vulnerable. And the people on the ground weren't being intimidated anymore, and their guns were better, and their aim was better, and anyone after the number 3 airplane, anyone that got to the target and was able to dive after the number 3 airplane was invariably shot down. So the age of the dive bomber passed. Now at Wright Field, they got this XP-51 number 4 production airplane. The number 4 is an interesting airplane in that it flew at Wright, it flew at Langley, it was here at the Smithsonian Institution, and it was traded to the EAA at Oshkosh, where it's on static display today, but it flew up to a couple of years ago. When Wright Field got it, they relegated it to the corner of the field. Curtiss had a great deal of influence at Wright Field, and they were also, the people at Wright were waiting for this new secret XP-46, which happens to be a P-51 lookalike. When the XP-46 finally showed up, it was 50 miles an hour slower than the P-51. In the meantime, they had pneumatic gun charger problems with the guns on the P-51, so they sent it down to Eglin Field for flight test. And instead of a report coming back about the guns, the report coming back was, where did you get this fantastic airplane, and why isn't it in the arsenal? At that point, Wright Field then sent the airplane to NACA for test and evaluation. Now, we found it was an excellent airplane in all categories except for roll. The aileron forces were not only heavy, you couldn't deflect the ailerons more than 10 degrees. There was a criteria in those days that a pilot shouldn't be obliged or couldn't roll laterally, wasn't able to push 50 pounds backhand or forehand, which of course would make the airplane roll, this side-to-side motion, and that should be restricted to 50 pounds. NACA said 30 pounds was enough, and today the criteria is 20 pounds. Now, when we got the airplane, the peripheral of the empty space, there's a line right here. This is the original ailerons. What we did was upholster this balsa wood filler on top of the current ailerons that the way it was sent into us. Now, obviously, if you stick a cusped area like that up into the wind stream, it's like sticking a catcher's mitt up there. The drag was ferocious. But when we upholstered this balsa wood filler, we sort of turned this into a laminar flow wing, didn't we? We turned this drag device into a lifting device, because now we had this cusped surface where, remember, the wind going over this point of maximum thickness would pinch down and increase speed, and we'd get lift. So now we went from a drag device to a lift device. And we were able then to increase the deflection from 10 to 20 degrees and stay within the 50-pound limit. As a lead-in to showing you what the effect of that was, I'd like to show you some of the protagonists in tonight's play. And this one in the upper left-hand corner is the Me-109, which was the plane that most of the German aces flew. The RP-51 had a we called it a Messerschmitt canopy. It had exactly that canopy. This was the Spitfire that the British went with as their primary fighter. They changed many engines. They went from like 1,000 horsepower at the start of the war, and they were able to get 2250 out of their Griffin engine at the end. They also did a tremendous amount of work on the wing, but the basic step shape stayed the same. This is the Focke-Wulf 190, which in my mind was the mean machine in the German arsenal and was the one to beat. Now this is the P-40, which was bought until 1945, but I think you can see that it was outclassed aerodynamically. It just doesn't look like it belongs in the same league. It looks old-fashioned, has a lot of frontal drag area, but because I think of Curtis's influence, and they were on the roll with the thing, they could produce a lot of them, they were bought and used. Now, this is a chart showing the comparison of the roll rates of the main fighters of World War II that we were concerned with anyway. Now, when we started, when the P-51 arrived at NACA, it would only roll at 48 degrees a second. Of course, when we doubled the deflection to 20 degrees, it was able to roll at 95 degrees a second. That was easy. But you notice that the Spitfire and the Focke-Wulf were almost head-to-head here at 130 degrees a second. We weren't within 75% of these two. Now, the conditions are, this was 200 miles an hour, and we were able to throw the ailerons full over. There was no force constraint. It was easy. Everybody could get his ailerons over. So at 200 miles an hour, everybody with full aileron deflection, this is what happened. Now, when we got out here at 350 miles an hour, it's harder to put those ailerons out in that kind of a wind stream. So the 50 pounds of stick force now becomes important. And 50 pounds of stick force out at 350 miles an hour would buy you 138 degrees in the P-51, 119 in the Focke-Wulf, 110 in the Spitz, and the P-47. I included those because there's a lot of P-47 people in the crowd, and the XP-51 original would roll at 80. So obviously, if you were a fighter pilot in an XP-51, it behooved you to get somebody to go head-to-head with you at 350, and if you were a Spitfire pilot, you would try to do combat at 200 miles an hour. I guess that's what that man meant when he said it all depends. Now, interestingly enough, birds can rotate at 300 to 500 degrees a second very easily, and some of them can rotate at 3,000 degrees a second. Did I say that right? Degrees a second. 300 to 500 degrees a second, and some of these birds can rotate at 3,000 degrees a second. Now, they can do it because they can rotate their body and they retract their downgoing wing. But all of this may be academic because pilots get disoriented when they're rolled on a sustained basis more than 100 degrees a second. Now, as a result of the fine flight characteristics we found during these roll tests, we decided that the P-51 would make a fine test vehicle, especially because we were trying to get to the speed of sound and through it, but the fastest full-scale tunnel we had was 125 miles an hour in those days. Even with scale models, we couldn't get over 0.81 or 0.80, which was, of course, 80% of the speed of sound. So we needed to know how airfoils would react in the real world at high speed. So we took our airfoil sections and we upholstered them onto the wing of a P-51 B model. And behind it, we called it a rake. It's this metal bar sticking up a couple of feet and went down a couple of feet and had a bunch of forward-pointing pressure probes. And the probes would be connected to tubes running to a manometer in the fuselage. Now, a manometer looked like a barograph or a seismograph. It had a big sheet of film going by some little lights that would deflect or trace light on the film. The film would be taken back to the flight research section, and an engineer and a computer in those days was a lady that had majored in math in college. And everything was done on a slide rule, a 10 or 20-inch slide rule. And we managed to get through the speed of sound and interrogatory using slide rules. But in any event, they would read this film in a microscope to the thousandth place, the deflections to a thousandth place. Now, in those days, the pilots for NACA, and I guess from all over, were the people who were left over from the 30s and 40s who were adventurers, and they came from all kinds of backgrounds. One of them in our office had flown in Venezuela when Caracas was a dirt street, and he was a roommate of Jimmy Angel, who had found Angel Falls, which is the tallest falls in the world. And they would arbitrage gold. They would get on their shortwave radios and find out what gold was in Colombia, and they'd buy some gold and run over there. It was apparently legal, but they were taking advantage of the airplane. So now we had this cadre of pilots married to engineers, and they certainly didn't agree. The engineers, of course, were looking for precision. They wanted steady state conditions. They wanted a side slip 5, 10, 15, 20 to the right, 5, 10, 15 to the left. They wanted to go 5,000, 6,000, methodical kind of data that they needed for this research work. And of course, those barnstormers would get out there, and if it was a rough day, they'd take records and they'd give them 10, 20, and 5, and they'd come back and throw this at these people. And it was amazing how they could work the data up. They could filter out a lot of this stuff, but of course the data was polluted, it was hard to work with, the results were circumspect. So we had Chief Pilot Mel Goff, who was a Johns Hopkins graduate, a Navy pilot, and an excellent engineer. He had, with Bob Gilruth, written the requirements for satisfactory flying qualities of airplanes, which was the Bible for designers and pilots. It still is today. All the control forces and their responses were measured and evaluated as a basis for designers and test pilots. It was Goff that said 50 pounds is ridiculous, 30 pounds is enough for roll, and 20 pounds stick force should produce a certain degree of roll. A bomber can be 45 pounds per G. Pull force is okay on a bomber, but we need 7 pounds on a fighter. He was the one that said, this is what we need, this is what we want. So he had a fantastic engineering background. And seeing what was going on, he said, you know, it's going to be a lot easier to make test pilots out of engineers than it is to make engineers out of test pilots. So he went into the division and he picked 3 of us, and I was one of them. I was in the flight research division as a practicing engineer. But I had 200 hours of flying time because I had been in a civilian pilot training program. Now, today that doesn't mean much, but in those days, an aeronautical engineer with a pilot's license was a rare bird. So when I got over to the pilot section, I then was in the position, of course, to see not only what was required, but what it took to get it. And I came down on the side of the engineers in the sense that I would go back as often as it took, if I had the fuel or the film, to get this kind of record. And the 3 of us would help read the records, and we also co-authored reports. Now, one of the things as a result of these dives was we found that we needed more directional stability. This airplane was a fine gun platform as it was, but we added this dorsal and we extended the tail, which I think even goes up beyond the picture here. So it made it a rock-steady airplane directionally. And the Air Force liked that so much that they retrofitted all of the P-51s in service, and they added the extended tail on all of the fighters that were coming down the line. Now, of course, while we were a basic research outfit, our mandate was to direct and supervise the scientific study of the problems of flight with a view to their practical solution, the war was on. And we had to address ourselves to the practical problems that were coming back from combat. One of these was that the P-51s escorting the B-17s over Germany were taking off with 3,000 pounds of fuel. They were flying 7 and 8 hours and fighting. They could fly 1,500 miles. And then coming back at night, and incidentally, the story went that when Göring first saw the P-51s escorting B-17s over Berlin, he said the war is over. And in essence, it was. The P-51s coming back and the B-17s were flying into storm clouds, residual storm clouds at night. And we heard rumors that the B-17s could be thrown out of the top of these storm clouds at 35,000 feet pointing down, and that some of the B-17 crew and equipment was being lost. So they gave us 2 old P-51s to do some storm cloud research with. I got one. The training school had turned loose. It had 3,000 hours on it. So Bob Baker and I, that were going to fly this test, waited until one hot day in July, and the sky was full of these tremendous cumulonimbus, these things that seem to go up forever, ferocious-looking clouds. And we got up in formation. We got level at 18,000 feet, and for some reason I was the first to go in, but the idea was that we would change places. And when you get close to these things, they're towering infernos, they're boiling cauldrons, and as you get closer, they really get wicked. But I plugged into this at about 18,000 feet, and I knew I already made a mistake, because not only was I on instruments, but I was using full aileron deflection to stay upright. So I flew for a little bit like that, and then all of a sudden I noticed a round hole in the cowling right ahead of me. And nothing happened for a moment. The plane kept flying. And then I saw that the oil pressure began to go to 0, and the RPMs began to increase. About that time, it threw a blade. And about that time, I came out of the clouds. And I could see Baker over to my left about a mile away, and with a loud whoosh, the whole plane was covered with yellow flames. At that point, it was vibrating and shaking tremendously. So I started, got rid of the harness and the helmet, the knee pad, and all the paraphernalia, and I started to roll up to the right. I had visions of myself falling out of the airplane. But as the airplane got to about 135 degrees, past about 90, I began to slide up and out of it. Now, if you put your hand out of a car at 60 miles an hour, you know what that feels like. At 180 miles an hour, the force is 9 times that. So you don't pop out of the airplane. You get smeared back along the fuselage at best. So when I saw that I was beginning to get creamed against the back of the cockpit, I was over at this angle, I was beginning to slide out, I pushed on the top of the stick and grabbed for my knees. And I can still see the numbers go by, 312, 114. Now, at that, there was a panel accident investigation after this, of course, and I was asked by someone, was I apprehensive about hitting the tail? And I said, when you're in a single-seater fighter that's on fire and you smell flesh burning, no. I fell for quite a way, and I felt cold. It was, I stretched out, and without making any motions, I rolled over, my feet went up, and my face was up, and I could hear the wind whistling. I had worn a lightweight summer flying suit, and I had a backpack. Normally, we wore the seat packs, which were the heavy-duty big chutes, and I had sort of a sport chute on for this flight. And when I opened the chute, it immediately began to oscillate. It would swing up at this point, and the bottom would collapse, and it would swing down, and it would go up to the other side, and that would collapse, and it was sort of a swinging. It looked like to me like it was a building up motion. So I tried to compensate by pulling on the risers, and it seemed to me a couple of times I got out of phase, and all I did was aggravate the thing. So I left it alone, and as I got down to about 5,000 feet, it stabilized, and then I began to realize how fast I was coming into the ground, and I thought that at minimum I'll break my legs. But I drifted into some trees, which snagged the chute enough to let me down relatively easily, and I went out into the field when Baker buzzed by in the other P-51. So I gathered up the chute, walked to the edge of this farm where there was a dirt road, and while I waited there, a farmer came down the road with a sedan with his wife and his children and some people. The car was full. So I stood on the running board with the chute on the roof, and he took me to an intersection where there was a telephone, and I called Langley Field, but the operator didn't want to accept the collect call. So they told me to wait there, that the paramedics and an ambulance were coming. The reason, some vignettes while I was waiting for them, was that the reason I know the propeller came off is that it came down in a acorn fashion, making a humming noise, and it hit a plowed field. Some people saw all of this, and it was picked up by and mounted later, mounted by the NACA mechanics. It was completely unblemished, one blade. The canopy hit a pond. Now the farmer who heard and saw something hitting the pond, he had seen this airplane spiraling down into the woods on fire, and he thought that was the pilot in the pond. So his mule, he was a peanut farmer down in Virginia, Portsmouth, south of Portsmouth, and the mule ran away with the plow. So he was coming to town to report this when he picked me up. The ambulance showed up 3 hours later, and it was obvious that the paramedics had been drinking, and they handed me a paper to sign that said that they had given me the liquor to drink because I was in a state of shock. And on the way back to Langley, we stopped at Smithfield at Mother Sykes' boarding house, which apparently was a famous place to have Smithfield ham. And they were convinced that the government was going to pay for a free meal for us because we were out after hours. And she didn't want to let me in, or whoever, it was either Mother Sykes or whoever she was, because I was improperly dressed. So they went to work and convinced her that a flying suit was actually a military uniform, therefore formal garb, and the poor woman let me in. Now that's before, okay, with the summer flying suit, and that's after. There was another combat report that we had that P-51s were losing their wings in dogfights, and it seemed to be associated with abrupt pull-ups at low altitude. But there was no consistent pattern, and there was no data, so we were asked to look into it. A senior pilot in our organization, we discussed it. We really didn't know what to look for, so we thought about running a preliminary test. So as the senior pilot and my boss, table of organization, took the plane, the P-51D that was assigned to us for the project, and he ran a series of tests. And what he did was to go to like 0.3, relatively slow, and do an abrupt pull-up. And the airplane went to approximately 3G. When it got to 3G, it stalled and buffeted. So he went to 0.4, did an abrupt pull-up. It went to 4G, more or less, stalled and buffeted. 5G, 0.5, it went to 5G. And then he got to 0.65, and he did this pull-up, and the plane went to 6G, but instead of stalling and buffeting, it buffeted and stalled. And then when he went faster to 0.7, instead of the G load increasing, it began to back down. It went to 5 Gs, but it was buffeting now and not stalling. And when he went to 0.8, 80% of the speed of sound, the plane would buffet at about 2G. So when he came back, he said, I don't know what and I remember he's doing abrupt pull-ups to get to these conditions. And he said, I don't know what the problem is. He said, it just doesn't seem like you can do anything to this airplane. I mean, I did these abrupt pull-ups through a whole speed range, and it never went more than 6G, which is only about half of what the airplane is capable of. So I was the pilot assigned to do the complete test. This was just a preliminary. So he said, Cavallo, you go up, and why don't you look into it at this point, 0.65 Mach number, where it seems that we're going to get the most G-force on the airplane. So I went up and got above the mark, and I came down on it, and I hit 10,000 feet at 0.65 right on the button, and I do an abrupt pull-up. And the airplane reared up. I had some mental thought about what's going to happen here, but this airplane reared up to a very high altitude and a very high angle of attack, and with a thumping jolt, it stalled and fell off. Now, that was easy enough to handle, but when I leveled off, I noticed I had 12 Gs on the instrument panel. Now, even with some gust in there, that was much more than was predicted or I expected. And I also noticed that the wings were rippled. So I brought the airplane back, and of course, a real heavy scene ensued about what happened. And of course, what happened was that there was a difference in definition between his idea of an abrupt pull-up and my idea of an abrupt pull-up. Now, obviously, what I had done was snap the stick back. Now, we all know that that's not the thing to do, but sort of emboldened by what I was told and encouraged to look for, to go on with this thing, I pulled the stick straight back as fast as I could. Now, obviously, if I had thought about it, he was moving according to the way he was moving his hand and demonstrating about it was taking him about 2 to 3 seconds to do what he called an abrupt pull-up. And in fact, it was, because he was hitting 6G, which is pretty good. And I should have known that snapping a stick back is something you only do in a snap roll, which is a stalled maneuver in horizontal flight. And it's not something you do in a fighter going 6.5. But obviously, I had hit the condition that these people were talking about. Now, it took us 2 years to get another airplane and instrument it and go out there and look into it further. But incidentally, the Loads Division ingeniously put this airplane up on a pylon, put me in it, and they shook it and buffeted it to find out what I felt, because we weren't properly instrumented. And now we knew the cause, but they didn't know the effect. And all I could do was say, yeah, that's about it, while I was up there being shaken and pounded. That's about what happened. And of course, what this condition was all about probably was either an anxious pilot or a scared pilot, and I guess that depends on whether the enemy was in front of him or behind him, would get to this condition, which we found was very insular. It was between Mach number 0.5 and 0.7 from 12,000 feet down. And there was no other time that you could do this to this airplane. The airplane would relieve itself. You couldn't pull it into this kind of a situation. And of course, what I had done was pull up to the ultimate load. Why I didn't lose the wings was a miracle, I suppose. And after, it took us 2 years to find out that this was a very isolated condition, but it could occur. And indeed, these people did have this problem. But again, what do you do about it? As far as I know, it was a report, and it's not something that a fighter pilot can absolutely fly within those boundaries. Now, probably the highest and best use of a P-51 as a test vehicle was when we used it as a full-scale tunnel. Now, again, the full-scale tunnels, even with scale models, wouldn't go past 80% of the speed of sound. And here we were trying to get through the speed of sound. So on a high humid day, with the sun at the right angle, you could see shock waves on a P-51's wings. It looked like an aurora borealis sticking up, and we knew where it was. So we told this to Bob Gilruth and the flight research engineers, and they cleverly decided that this is the grist to make a high-speed tunnel. what they did was take half-scale models. Now, I don't mean it's half the size of a real airplane. It's cut down the middle, and it's mounted on the wing. You see, it's mounted on the wing of a P-51. There's a post that goes from the model down into the wing, and in the wing, a very sophisticated miniature wind tunnel mechanism. And this vane out here measured the angle of attack of the incoming air. This model was capable of being rotated through all angles of attack. At the same time, we could measure the drag, the lift, and the rolling moments. Now, at 0.81 on the fuselage, 80% of the speed of sound, again, because of that pinching effect, the air over the wing was 40% over the speed of sound. So we had the ability now to test models through the speed of sound. The technique was to climb to 35,000 feet, push over, hold a steady condition from 35,000 feet to 12,000 feet, and then pull out, while the model was rotating through these angle of attacks. All of the major fighters were tested this way. This was the F-88. I don't think it ever became a current fighter. And it was also the only data available. X-1 was tested this way. Interestingly enough, if you really want to know what it feels like to do a dive like this, just go to the biggest cynic railway you can find, and as you sit there, apprehensively strapped in, and methodically click to the top, and then everything gets quiet, and you have a fine view, and then you get pushed over, and your stomach comes up in your mouth, and you thunder down this slope, and at the bottom you can feel this G-force. That's exactly what a dive, and these dives were like, only they just took a little longer. Now, this shows the model now on the whole wing, mounted, ready to go, and the mechanic is loading film in the manometer. This whole wing now is full of this instrumentation. And this is the whole scene. This is the P-51H. There's the test section. Notice it has the dorsal and the extended fin. And this helmet is about 100 meters from here on display. Now, we had to deal with compressibility. We didn't, this was the big bad word. We didn't make any tests with compressibility, and the effects of compressibility, but we had to live with it and deal with it. So we got to know it. This would be a typical condition in a dive. You'll notice that the shock wave is standing at the point of maximum thickness. Behind it is this area of turbulence and drag. Don't forget that wing keeps wanting to pitch down. It's like a dog on a leash. It never gives up its desire to roll over and pitch down. Now you have this flow separation and the downwash. Well, once the flow separation comes on, once you get this turbulence, the downwash is destroyed. So the pilot applies up elevated to compensate for this lack of downwash. He has to apply up elevated. So schematically, this is what it looks like in the dive. Now, to put the elevator up at these high Mach numbers took quite a bit of force. And you had to be sure that you left enough force left over that you could pull out from the steady state condition. And consequently, on the pull-out, you'd find yourself pulling quite a bit of up elevator, and the airplane would probably, let me touch on one other point. As you came out of the dive, of course, the wing would finally go subsonic, and the shock wave would stop. As the shock wave stops, the downwash reappears, and now all of a sudden you have a very effective elevator, and you have to be very careful that you don't apply, that you get off some of that elevator. You back down, otherwise you'll put an inordinate load on the wings and you'll lose it. You'll lose them. So it was sort of a situation where would start in the dive, you'd start holding up elevator, you'd pull a little more up elevator, the thing would start out of the dive, the compressibility, the shock wave would stop, and then you had to back off on the elevator. And if you got it all together, you'd get a nice smooth 3 or 4 G pullout. Now, on the other hand, if you got going too fast, then you'd find that this rolling moment of the wing would be too powerful to overcome, no matter how much up elevator you pull. And this is what is referred to as tuck compressibility effect. Literally, you just didn't have the strength, either physically or aerodynamically, to get out of that situation, and the airplane would go in. So you had a very small area to fly in here. If you pulled too hard, the wings could come off. Actually, there was another consideration. In the P-38, when Verdun got killed in the P-38, what happened to him was that when the downwash reappeared on the stabilizer and elevator, it took them off. It didn't take the wing off, which was most of our concern. This is what came off. That download was so high that he lost his tail and rudder. So we were flying in an area that was delicate, to say the least. You know, this business of shock stopping and the effectiveness of the controls reappearing. If you've ever been in a skid in a car on ice, you know how you turn the wheel into the skid, and then all of a sudden you hit a dry patch and you get that shock. That's pretty much would replicate what we're talking about here. So most of the pilots would fly to 0.75. In other words, in the dive, they would reach 0.75. Because I was doing this 2 or 3 times a week, and because over many months, I would try to fool around on the edge of this thing, and encouraged by the engineers, and I flew to 0.81. At 0.81, it took one hand, all I could pull with one hand to come out. At 0.83, I would use both hands to come out, but that's about as fast as you could go in a P-51 and still recover. Now, one of the joys and fringe benefits of flying for NACA in those days was that we would conspire to meet, to do combat, if we were out on various tests. And the favorite place to meet in those days, which was a big secret from the boss, but I'll tell you now, was 20,000 feet over the south end of the James River Bridge. And one day I knew that Baker and Breeder were out on test programs. One was in an F-8F, one was in an F-4U, and I knew what time they were going to meet. So there was a nice P-51H sitting on the line. We were through with it. It was going to be returned to the Army. It was full of fuel. The guns were back in it, and I had nothing to do. So I asked the boss if I could take this P-51H and do some air work. And he said, okay. He said, just don't bend it. Now, I don't know whether he was being sarcastic because of my previous experience, but in any event, I take this P-51H, and of course I head for the battleground. And as I came up, climbing up, I could see that the two of them were dogfighting, and incidentally, some of the best battles of World War II took place in that location with some of the best equipment that this country had. So I start a Nimmelman is a half of a loop with a rollout on the top, and I had envisioned myself ending up on the tail of this F-8F like a big champ. One thing I forgot about was that the fuselage tank was full of fuel, 85 gallons of fuel. I had never flown a P-51. We never did any test work with 85 pounds of fuel behind our heads. But what that does is move the center of gravity back. What moving the center of the gravity back does is reduce the stability of the airplane and made the stick forces very light, number one. So now I'm coming over on my back with these very light stick forces, which I'm beginning to realize. And then I began to think I'm going to end up in the middle of these guys instead of behind them, so I pulled in on the stick. Now, any pilot in the audience knows what I set myself up for, which was, of course, an inverted spin. And the airplane immediately took 2 turns and then rolled over and began to spin right side up. and it was the most wicked kind of spin. The horizon stayed absolutely in the middle of the windshield. So I went through everything I learned in civilian pilot training program, which is PARE, you know, power off, ailerons neutral, rudder against, elevator forward, and I think the airplane laughed at me because it was like spit in the ocean. Not only that, a couple of times so then I began to invent stuff, ailerons with, against, rudders, and a couple of times I thought it was slowing down, so I applied power, which of course any pilot will tell you is absolutely the wrong thing. The thing speeded up. So I then began to resort to the ballet dancer's twist because I was beginning to get dizzy. And the only thing I can remember then, and I can remember it now, not how am I going to get out, what am I going to tell the boss? There's no way out of this thing. So obviously, and I didn't think about it, that getting out of a spinning P-51, impossible. But when I got down to 5,000 feet, or somewhere between 10 and 5,000 feet, I had to make a move, so I got the canopy back. The minute I rolled that canopy back, whether it was the control application or it was the change in airflow over the tail, the P-51 pitched and down, and I was able to fly out. Now, when I got level, I couldn't stay level. I was falling all over the sky. I had a terrible case of vertigo, and I kept thinking I was going to fall back into another spin. After a couple of minutes that I stabilized myself, I look up and I see Baker in his F-4U sitting on my wing. And incidentally, the man in the F-8F never saw me at all. And then I heard Baker's voice on a discrete frequency we were on say, "Cavallo, I thought you were dead." Now, I flew at a time when test flying was changing from the Clark Gable and the test pilot scenario to the highly qualified Air Force Academy graduates with 2 years of flight training that you see today. But my connection with the era that preceded me was when I spent 6 weeks in General George Marshall's airplane with a CAA pilot. He had air transport rating number 2. I thought he was an old man. He was in his 50s, I think, in those days. And we were looking for a site. We were flying VIPs from Washington here. We were looking for a site of a new high-speed station. And he had been a Navy pilot, and he had been a company test pilot. So he regaled me with the stories about test flying in the 20s and 30s, and he was interested in the work I was doing, too. He had flown every low-frequency range in the country, and he had tested most of the bi-wing fabric-covered airplanes that the Navy had accepted up till, I guess, the late 30s. Anyway, apparently the procedures in those days was that a plane would be selected for demonstration to the Navy for acceptance, a model, and they would be required to do all of the tests on one airplane, the dives, the spins, the gunnery, and of course the piece de resistance was on final day, the airplane would do a terminal velocity dive straight down. They could do those with those planes in those days, throttle full forward, and then a 9G pull out at the bottom. And as he told me, he says, you know, if any major work is done in this airplane during this week of flying, he says, it's rejected by the Navy. So the airplane has to be left alone. All you can do is service it. Now, he says, you know, you got to be a nut, he said, to accept that kind of thinking, he said. And test pilots have no friends, he said. The company isn't going to help you. So if you see something, he says, in fact, if you quit or you say that this airplane, you know, I'm not going to fly it anymore, it's getting dangerous, it's something, the engine mount is loosening up, I don't know. He said, they're going to be mad at you. They're not going to be happy. So he says, he says, if that's what they're doing to you at Langley, he never really got a good handle on what I was up to. He said, you just get a mechanic and you sneak in there. Just go out in the find a secretary. He said, it makes a great aiming point. He said, when you pull out, nobody complains about the noise. If anything falls off the airplane, he says, it doesn't hurt anyone. And if you go in, they know where to look for you, and you'll save the cost of a funeral. test flying was an enjoyable and an important part of my life, obviously, and it provided me with a lot of very unforgettable experiences and philosophies. One important one was as a result of a dogfight I had with Bob Baker. He was in an F-8F and I was in a P-51D. Now, I don't want you to think that all I did was take P-51s out and have a good time wringing them out, and especially with Bob Baker. But it just so happened that at many important incidences, he was along. Some of them I'm not talking about tonight, but really border on the incredible. And this particular day, anyway, we were spiraling down in a 4G spiraling descending turn. And I had a G-suit on. It was the only time I'd ever worn a G-suit. We never used G-suits in these tests. And a G-suit is like a big corset that covers you from ankles up to your chest. And it fills with air as you pull G on the plane. And it holds the blood from running down out of your upper torso so you don't black out. So in this 4G, he didn't have one, and he didn't know that I did have one. So he was hanging in this 4G turn with me, and I could look across and see his head nod forward as he blacked out, and he would ease off, the F-8F would ease off, and he'd come to and take a look and pull back in again. He was taking fantastic punishment. And as he said later, he couldn't understand how I could take it, and he couldn't. But we finally ended up down at quite low altitude, so we broke off, got into formation, came back to Langley. And the boss was waiting for us. And he called us in the office. And he said, I've got a report that you two were dogfighting over the Yorktown Naval Mine Depot at under 1,000 feet. And I thought, oh, we're going to be grounded, fired, jailed, or all three. And he said, I just want to ask you a question. If either one of your engines had stopped in that position, what would you have done? So in response to our lack of a response, he said, I'm going to tell you something I want you to remember. You can do anything you want, with or without an airplane. Just be sure you have a way out. And my way out tonight, ladies and gentlemen, is to tell you that in recalling the over 50 different types of planes I flew, ranging service airplanes, ranging from helicopters before VJ Day to bombers, from single-ponton seaplanes to flying boats, and as of last month, gliders, I can say without reservation that the P-51 is the best airplane I ever flew. It certainly was the best airplane of World War II. It may be the best airplane that ever was. And it was and still is, in my opinion, the Cadillac of the sky. Thank you.
Take a drink, but you can use this. Thank you very much, Steve. That was, I sure learned a lot from that I didn't know, and I found it fascinating. Jesus, excuse me. Scary, too. The only thing I didn't like was what you said about a P-40. I hated to think that for 2 whole years I was flying an airplane in drag. I think we can take a few questions now if anybody would like to ask some. Right there in the middle.
Up at Edo, did you test fly the C-47 on floats?
The question is, did you test fly the C-47 on floats while you were at Edo?
Well, Ralph Romaine was in charge. Ralph Romaine was in charge of that project, so I was the co-pilot. I was my work at Edo was the XOSE-1, which was that single ponton seaplane, and I did most of my work as a pilot in command. I was only the, Ralph Romaine had those projects. I was also the co-pilot on a B-17 when we dropped lifeboats.
Those Dumbo boats,
Yeah,
Yeah, a friend of mine is one of the owners of that C-47 that's on floats up in Greenville, Maine, and he said it flew very well. He's going to send me some video of it. I'll try to get it shown here or something if we get it. Was a G-suit standard for a P-51 in combat?
Can I give that back to you, Don? Because
Yeah.
Don flew combat and he flew 51, so I...
It was in Europe later. They got them after they started flying 51s, and then later they got the G-suits. But we had Mustangs in China, and I never saw a G-suit till I got home. Did the supercharger make a thudding noise when it cut in at 19,000 feet, and why did it?
It certainly did, and I don't know why. And the first time you hear it, it's scary. But it's interesting that it was automatic, and that the pilot had no control over it. But a couple of the aces that I talked to that came back from combat, and we would try to interview these people, said that he became an ace by sitting just under where the supercharger would kick in, and he'd wait till somebody he engaged somebody in combat, and he'd pull up like 500 feet, and this supercharger would kick in with a thud. You're right. I don't know why it did it that way. It was like an old Buick transmission or something, and but he'd get this jolt, this shot of power that would, from which he was able to overcome or win this combat. So he was using this situation, and apparently you could fine-tune it. When you got to know your airplane, you could tell within a couple of hundred feet where this thing was going to kick in.
And when we were flying in formation, after the first few times, we leave it off until we got above the altitude, then cut it in, so everyone would cut it at the same time. Else the formation would, one guy would zip out, and all of a sudden, then the next guy. It was kind of weird up there. Yes, they were sent over there for that purpose, with the extra tank in the fuselage, especially gave them the long range. And yes, they did use drop tanks, wing tanks. They weren't belly tanks in a Mustang. The question was, did they, at Ames during the war, towed a P-51 without a propeller up to altitude so it could dive and get a higher Mach number because it lacked the drag of the propeller?
That was a good idea. It was flown by Jim Nissen, who was a pilot at Langley. I think he's the fixed base operator at San Jose now. And it should have worked. The propeller is the thing that holds you back, actually. That was the main drag. A P-51 without a propeller on it had all of the possibilities of going through the speed of sound. And I think that's maybe what they were thinking of. And it's unfortunate that the 61 unhooked, I think, and the cable came back over the P-51, and it wrecked the P-51. And in those days, it was amazing how easy people could get discouraged, in the sense that if you lost the test vehicle, the project just sort of stopped. Everybody got discouraged. They just wouldn't go on. So instead of getting another P-51, they scrapped the project. And I saw that happen a couple of times on flights and on projects that had great possibility. But if you lost the equipment, Geoffrey de Havilland, with the British, I think, were ahead of us on going through the speed of sound. And when he, unfortunately, tried to demonstrate that plane at low altitude, he wasn't ready for the aerodynamic forces that happened to him, and he lost the airplane, and the British then backed away, and it wasn't until, I guess, 2 years after Chuck went through the speed of sound that they finally did. But they had the equipment.
Who, the British? I don't know. Do you know how fast they got? No.
They didn't have much of a chance.
The one in blue shirt up there? The question was, did the Focke-Wulf 190 and the Tony Japanese fighter, were they able to outperform the Mustang? I was in China, and I never heard of one doing it. We only had a few Tonys over there, so I really couldn't answer. But I never read about it. I was supposed to be the Air Force test pilot on the Tony that we had captured, but it lost an engine and crashed while they were ferrying it down for me to fly it. So I never got to. So I don't know. Do you know anything about that, Steve?
No, apparently we never felt, at least on the basis of the statistics that we had, that we should even include it in this comparison I think that the Japanese fighters, except for the zero, maybe in turn, but in roll, I don't think it held a candle to the Spitfire or the Focke-Wulf 190. The Focke-Wulf 190 was the Sugar Ray Robinson of the Luftwaffe. It was pound for pound, it was their best shot, and I think was the one that most of our people were concerned with, don't you?
Yeah. More, yeah.
Could you tell me what the technical or mechanical difference between the Merlin and the Allison was?
He wants to know the technical difference between the Merlin and the Allison. What was the reason for the Merlin's superiority? Just as an aside, we had a poem over in China. It was, "But Merlin keeps them whirling when Allison kicks up a fuss and lets you down in places where you have to take a bus."
I'm not going to touch that.
No, actually, the main difference in the two was the two-speed, two-stage blower that gave it the altitude capability. P-40, you could hardly get it up about 25,000 feet. It was just staggering up there because you lost so much power. We had no supercharger, where the Merlin engine was supercharged. Now, I flew P-40s with Merlins in them without the superchargers, and they flew just about like the one with the Allison. The Merlin was a wonderful engine, very extremely reliable and very good engine, but the blower is what made it the high altitude great airplane that it was. Way in the back.
What is the level of noise and vibration? Bearable or what?
Oh, yes. What is the level of noise and vibration in the cockpit? Is it bearable? I guess it is. We all bore it. I didn't think it was aggressive. It sounded like a good fighter is what it sounded like.
Yeah, it's somewhat like a buzzsaw cutting wood, but the only thing about the 51 was it was a hot cockpit. You were sitting on
It was hot, yeah.
You were sitting on a radiator in a very small enclosure, and other than that, it was interesting that if you spent a couple of hours in it, though, at least I found that I would be tired. I'd come home and take a nap, and for a guy in his 20s to be taking a nap was unusual. So I don't know how the pilots in Europe flew that thing 7 to 8 hours, and it really was a test of strength as far as I was concerned. Now maybe Don can.
No, we didn't fly that kind of missions in China. Maybe 4 hours, but it was hot, but it wasn't that unbearable. We'll take about 2 more questions right here.
So are you implying that it was a hard, physically hard, a lot of work to fly the airplane that made you tired that way?
I think it was the noise, Don.
The question was it the strength required for the controls that made you tired, and it was the heat and the noise wore you out. And flying at high altitude with oxygen for a long time is very uncomfortable. But you're much better off than without it. One more. Way in the back there.
Have you ever flown a Spitfire, and if so, would you compare the two?
Have you ever flown a Spitfire, and would you compare the Mustang and the Spitfire?
I flew the Spitfire 5, and it didn't compare to the Mustang. But the British were very diligent, and they, in fact, they changed 5 wings on the Spitfire, trying to get it to roll like the Focke-Wulf. And what they did was go as far as they could with the aileron design, and then they kept changing the wing to get a lower damping moment wing. In other words, a wing that wouldn't resist rolling as much. And they ended up with the typical short, fat, stubby, low aspect ratio wing, which was very easy to roll. And they were able to get that 130 degree a second roll. But in terms of easy to fly, I think their ultimate Spitfire, that 9, I don't know how that would have compared to a P-51H. I have a feeling that probably the H would have been a better airplane. We could get very close to 500 miles an hour out of that P-51H at 35,000 feet, and the roll rate maybe wasn't as good as the P-51 as the Spitfire, but in every other category, you really felt like you had your hands on an airplane. The Spitfire always felt a little bit tinny to me, but I don't know. That was just my own impression.
Thank you all very much, and thank you, Steve. It was extremely interesting and fascinating lecture.
Thank you, Dan.
Thank you. Would you please leave from the rear, and Steve will be down here in the lobby for anybody who would like to talk to him or get an autograph or anything like that. Thank you again.